Hi everyone, this is the second lesson recording for week 7 of distance learning IM1. Now we're going to be tackling solving absolute value inequalities. So we've learned how to solve regular inequalities with one variable and two variables, and we've learned how to solve absolute value equations. Now we're going to combine all of them together and say solving absolute value inequalities. To start off with, I am going to give you notes first. So here I have the steps outlined for you. Step 1, you write the absolute value inequality as with an equal sign. Okay? Then write your two equations and solve to get the two boundary points and check a value into the original inequality to see where to shade. Whether you're either going to be shading in between the two boundary points or outside of the two boundary points, and then finally give your inequality answer. So at this point, please pause the video and take these notes down, and I am going to explain these steps as we go through the example. Okay, so assuming you have taken the notes, let's go through these steps. So the first step was to rewrite this absolute value inequality. This is absolute value expression with an inequality sign. So it's an absolute value inequality. We want to rewrite it with an equal sign. So that means we want to convert that to absolute value of 3x minus 6 is equal to 30. That's what I mean by convert it into equal sign. Okay, we are going to be dealing with the inequality later on, but for now, convert it to equal sign. That means from here, step 2 says to write your two equations and solve to get the two boundary points. So from here, we can come up with two possible equations. One is the positive version and one is the negative version. So that's going to be 3x minus 6 is equal to 30, or 3x minus 6 is equal to negative 30. Okay, those are my two equations. And then solve. How do I solve this? Add 6 to both sides. Leaves me with 3x is equal to 36. Then divide both sides by 3. And that leaves me with x is equal to 12. What about the other equation? We add 6 to both sides again, and that leaves me with 3x is equal to negative 30 plus 6 is going to be negative 24. Then divide both sides by 3. That leaves me with x to be equal to negative 8. So now I have found my two boundary points. So I am going to place that in my number line. So find your negative 8. If I have 0 here, negative 8 will be to the left, and positive 12 will be to the right, maybe a little bit farther than 8. So that's going to be about 12 right here. Now these are my boundary points. That means I can draw my circles right on those 2 points. Now I need to be asking myself, should I be shading this in or leaving it as open circle? To do that, you have to look at the inequality sign now. Okay, I told you we're going to get back to it. This inequality sign is less than. That means this is going to be open circle. So we're going to leave it as an open circle now. Okay, then from here we are going to check a value. Okay, so the easiest one always is x is equal to 0. So if we're going to test x is equal to 0 by checking a value into the original inequality to see where to shade. So we are going to test x is equal to 0 into the original inequality. So that's going to be 3 times, instead of writing x, I am going to write 0. Minus 6 is less than 30. We're going to see if this is true. 3 times 0 is just 0 minus 6. We have not dealt with the inequality sign, so that remains. Everything else is the same. 0 minus 6 is just negative 6. Still inside the absolute value sign. And then now we can get rid of the absolute value symbol as we apply the function. So what is absolute value of negative 6? It's just positive 6. Is this true? Okay, is 6 less than 30? Is 30 the bigger number between these two? Yes, this is true. Okay, this means that the solution, so here we need to make a conclusion. The solution includes section with x is equal to 0. Where is x is equal to 0? It's right here. It includes that. That means this is part of the solution area. So I am going to shade this in like so. And I know that this is an open circle. This is also an open circle. So this is my solution. Oh, I'm sorry, you cannot see what I wrote. Okay, so the solution includes a section with x is equal to 0 because we came up with a true statement at the end when we were testing x is equal to 0. So the solution includes that section. So what is the answer going to be? The answer, if I was to rewrite this, that means we actually have what we call compound inequality. You have two different conditions. If you just look at this condition, you're looking at x, the value of x is bigger than negative 8. This is this half. Okay, so that would shade all the way like so. But that is not the only condition. We also have this 12, so that means 12x is less than 12. So x is less than 12 means we are shading this section all the way going to the infinity. So we are looking at the section that is overlapping. So we say that the condition is AND condition. So because we are looking at overlapping conditions, so it's AND. So we're looking at the solution area now becomes, to write this as a solution, x is greater than negative 8 and x is less than 12. It needs to satisfy both the conditions because we're talking about the overlapping area. Or in another way of seeing this is it's between negative 8 and 12, but it is less than. So they are the same way, same thing, but just writing it in two different ways. So these are two different ways of writing the same solution. Okay, let's try another problem. So second example is absolute value of 2x minus 1 is greater than 23. So again, I am going to rewrite this inequality as an equation to find my boundary points. So from here, I am going to get my two equations. So that's going to be, first equation is going to be 2x minus 1 is equal to positive version, which is 23, and 2x minus 1 is equal to negative version, which is negative 23. And then we're going to solve as we've always done. Add 1 to both sides, leaves me with 2x is equal to 23 plus 1 is 24. Then divide both sides by 2. And that leaves me with x to be 12. The other equation, you add 1 to both sides, which leaves me with 2x is equal to negative 23 plus 1 is negative 22. Then divide both sides by 2, and you get x is equal to negative 11. So you have two solutions. That means I have to put it in my number line. And so you have negative 11 here, and 0 will be somewhere here. And then positive 12 will be approximately same distance, but maybe a little bit further. And so, okay, all right, actually, I am going to change this inequality to greater than or equal to, just to make it a little bit more different. Okay, so then now looking at this inequality, should I be shading, should it be a closed circle or open circle. Well, it's greater than or equal to. So the equal to sign tells me that 11 and positive 12 is part of the solution. So I am going to shade it in. So this tells me this is going to be closed circle. Okay, and now I need to check. Okay, I am going to test again with x equals 0 into the original inequality. So that becomes absolute value of 2 times 0 minus 1. Is that greater than 23? What's 2 times 0 is just 0. Minus 1 is just negative 1. Absolute value of negative 1, is that greater than or equal to 23? Absolute value of negative 1 is just 1. Is that true? Well, no, this 1 is not bigger than 23. So this is false. So that means that the solution excludes section with x is equal to 0. So x is equal to 0 is here. So it excludes this section. That means our solution is going to be outside. This is going to be outside like so. So this is my two solution area. So in this case, this tells me that x is less than or equal to negative 11, and this tells me x is greater than or equal to 12. So in this case, the condition is all, because you can never have any numbers that satisfies both, but it can satisfy one or the other inequality. So the answer is x is less than or equal to negative 11, or x is greater than or equal to 12, and this will be my answer to the solution. Okay? Alright, so at this point, I am going to ask you to do two practice problems. The first practice problem is here. Absolute value of 4x minus 3 is greater than or equal to 11. So please copy it down. And the second absolute value inequality is absolute value of 2 over 3x plus 2, closed absolute value, is less than 8. So please pause the video right now and solve these two quick problems. Okay, I'm going to assume you are done, and let's go through the answers. So first, I convert that inequality into equation with the equal sign, then I come up with the two equations from the absolute value, one positive version, one negative version, and then solve, and I get x to be 14 over 4. I do need to simplify it as much as possible. I divide numerator and denominator by 2, and you end up with 7 over 2, which is really 3.5. The other solution is negative 2. Then I mark my boundary points, and in this case, because of this inequality sign being greater than or equal to, the equal sign tells me that I need to shade it in, shade the circles in, so it's going to be a closed circle. And then you need to test 0x to be 0 into the original equation or inequality, and then come up with a false statement, which means x is equal to 0 is not part of the solution section. So which is the part? Then it's going to be outside those two boundary points. So the answer is x is less than or equal to negative 2, or x is greater than or equal to 3.5. So that's the first problem. The second problem looks like this. I am running out of time, so I will explain as much as I can. So you come up with two equations by converting it into an equal sign, and then you get the two boundary points to be 9 and negative 15. Mark those with open circle because inequality sign says less than, and then you test x to be 0, which gives you a true statement. That means it includes that point, so you shade that in, and this is my final solution.